Spiral 3. Hopefully I'll find it. Nope. There we go. Okay, so Sarah wants to make fruit baskets. She has 32 oranges and 20 apples. Each basket will have the same number of oranges, the same number of apples. She'll put the greatest number in each basket. How many baskets will only have oranges? Ooh, okay. So this is a GCF problem, right? Because you want to split things up. That's a hint. You want to divide the oranges and apples into equal portions, equal amounts. So that's definitely a hint. That's a GCF problem. Using the latter method, I will choose 4. 4 goes 32 8 times. 4 goes 25 times. Oops, that's it. GCF is this number, or the product. If there were more than one number, you would multiply them. So GCF is 4. What does that mean? It means that I can make baskets, right? And in each basket, and here's my basket, I'm going to put either 4 oranges or 4 apples in each basket. So let me make baskets. I don't know how many baskets I'm going to make. I'm just going to make quite a few. So let's talk about 32 with the oranges and 20 was the apples. So we're interested in the oranges. So there are 32 oranges, and each basket will only have 4 oranges. Well, if I put 4 oranges here, 4 over 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 here, I'm going to need 1, 2, 3, 4, 5, 6, 7, 8 baskets, and that's what this number, uh, in this case, will tell me, right? So each basket will have 4 oranges, but I'm not interested in the number of oranges in the basket. I'm interested in how many baskets will have only oranges. Well, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 baskets full of orange. And likewise with the apples, if they were to ask, again, you're going to put 4 apples in each basket. 4 here, 4 here. These are apples, by the way. 4 apples here, 4 apples here. So that's 4, 12, 4, 8, 12, 16. You would need 5 baskets, and that's what this number in this case means. Okay, so the answer to this question, she will need 8. Not she will need, sorry. 8 baskets will have oranges, so that would be the better question. 8 baskets will have oranges. Okay. Sam plays basketball every day, every 8 days, and plays soccer every 3 days. How often does she play both sports on the same day? So if she just played today, so imagine if she just played soccer and basketball today, how many days from now will she play both sports again? Because obviously she doesn't play them on the same day all the time. So this is something that repeats over and over and over again, and we want to see when it meets in the future. So this is an LCM problem. So 8 and 13, find the LCM. You can do this. The only number that goes into 8 13 is 1, so I know that I'm going to multiply these 3. If you wanted to, be my guest. You can list your times table, 8 times 1, times 2, times 3, times 4, and so forth, until you find a multiple, a number that shows this line, it's the same. So that might take you a while, depending on the number. So in this case, the multiple that would show up, and it's 13 times 8. 4 goes to 104. So down here, as you go, it would show up. 104 would show up, and 104 would also show up. Excuse me. Okay, sorry for the interruption. So 104 is how often does she play both sports on the same day? So in 104 days, okay, in 104 days from today, she would actually play basketball and soccer on the same day. That's a long time. So you would write in 104 days, she will play basketball and soccer on the same day. And soccer on the same day. Okay, let's move on. Tina says the prime factorization of 80 is 2 times 2 times 4 times 5. Is she correct? Find the prime factorization to determine if she's correct. Explain your answer. Well, I don't know. Well, one way you can tell is if you actually multiply the numbers out. If you multiply 2 times 2 is 4, 4 times 4 is 16, and 16 times 5, is it actually 80? It is, so she is correct. So, but the question is actually for you to actually do it, to just double check. So let's do it. 80 breaks up into 8 and 10. 10 breaks up into 2 and 5. They're both prime numbers. We can't continue, so we circle. The 8 we can break up in 2 and 4. The 4 we circle because it's a prime number. And the 4 breaks it up in 2 times 2. Am I doing something wrong? 20 times 4 is 8. What am I doing here? 8, 2 and 5. 8 is 2 and 4. Okay, what am I doing wrong? Okay, something I'm doing wrong. So here, 2 times 2, 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. Actually, this is correct. I don't know what I'm doing on here on the top. So via the prime factorization I just did, I actually got 2 times 2 times 2 times 2 times 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 5 is 8. So this is correct. And we will actually write this as 2 to the 4th times 5th. I see what I made a mistake. So Tina actually did it. This does equal 80, but she didn't write this using all prime numbers. This 4 over here that she used does break up into 2 and 2. Remember that this is the prime factorization. So we're taking a number and writing as a product of prime numbers. So we're using only prime numbers to get to 80. And in this case, she didn't use only prime numbers because she used the number 4, and number 4 is a composite. Okay, it does multiply to 80, but unfortunately the 4 is a composite, so that's where her mistake was. So the right answer would be 2 times 2 times 2 times 2, prime, 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 and prime, times another prime 5. That gives you 80. And writing it in exponential form is 2 to the 4th times 5 equals 80. Tomas says 3 to the 4th is the same thing as 3 times 4, which is 12. Do you agree? Ugh, hopefully not. No. Okay, 3 to the 4th power is not the same thing as 3 times 4. It actually means it's 3. Okay, so it's 3 times itself 4 times. So 3 to the 4th power actually equals to 3 times 3 times 3 times 3, which gives us actually 81. Okay, so you would write the whole explanation. Okay. Use the security property. Here we go against the birds attacking the pigs. What am I doing? Any birds here? Here we go. So the 4 is multiplying each of the terms, each of the numbers inside via multiplication, right? So we get 4 times 5 plus 4 times 8. 4 times 5 is 20. 4 times 8 is 32. And 12 plus 2, and that's equals to 52. So we just created an expression. So this, all that equals to 52. Or we can use this one. Okay. Factor out using the greatest common factor. So we want to go backwards almost. Okay, right? We're gonna take the biggest number that goes into 28 and 42 and rewrite that expression going backwards. Okay. So what's the LCM? Sorry. GCF of 28 and 42, the biggest number, the greatest common factor between these two has to be 12. Let's see, 7 goes to 28 4 times, 7 goes to 42 6 times. Oops, we can go on. 2 goes to 4 2 times, 2 goes to 6 3 times. No other number can. And GCF is a product of these two numbers, which is 7 times 2. So our number outside is going to be 14. 14 times what equals 28 would be 2. 14 times what gives you 42, which would be 3. 14 times 2 is 28. 14 times 3 is 42. And that's what these two numbers also come in handy. So GCF is 14. and the two numbers inside are 2 and 3. And we can always double check by applying the distributive property. Sam wants to give 7/8 of her cake to 3 of her friends. What equal share of the cake will each of the friends receive? Solve 2 ways. Okay, so 7/8. Let's use a model. I have 7/8 of something. Half, 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 half. This is my 7/8. Shade up to 7 pieces. So I have 7 pieces and 3 people. Obviously that's not going to go evenly. So what I can do is take the first one, cut it into 3 parts. So here's Alex, Brianna, and Charles, right? They each got 1 piece. I'm going to repeat the same process all the way across. Right? If I cut everything 3s, because I have 3 friends, that should work out. So this is all going to be, forget who the name is, Alex. This one was go Brianna. And the last one will go to Charles. So the last row here goes to Charles. So when doing this, don't forget that we also have to cut this one, even though it's not there anymore. So how much of the 7/8 of a cake do each of your 3 friends get? Well, they each got 1, 2, 3, 4, 5, 6, 7. They each got 7 out of a total of what? There's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 7 out of 24. Brianna here got 1, 2, 3, 4, 5, 6, 7. Good. 7 out of 24. And Charles got 1, 2, 3, 4, 5, 6, 7. So they each got 7 out of 24. So that's one way, right? So let's do the other way. 7/8. That's what I have. And I'm going to share with 3 friends. Okay. We can put this over 1. And the LCM is 8. This stays a 7. 1 becomes an 8 times 8. And the top is times 8. 3 times 8 is 24. Common denominators, yes. Cross and cross. Now I can write that as a fraction. 7 of 24. Look at that. We got the same exact answer. So either way, they're both 7 over 24. Okay, so there's a couple of questions here. Oh, but division of decimals, which we haven't done, but I stuck it in here just to see how you would do. Let's see. So Taylor earned $80.75 last week after working for 8.5 hours. How much does she earn per hour? So definitely a division problem. So let's set this up. 80.75. You're going to divide this by 8.5, right? So if you remember anything about division of decimals, to make life easier, okay, one of the tricks that we have is to multiply this, well, move the decimal 1 over, so that becomes a whole number. And if we move this decimal 1 over, we move the decimal here inside 1 over. In essence, we're multiplying 8.5 times 10 to make it an 85, which is a whole number, right? And if I multiply the inside by 10, the outside by 10, I must multiply the inside by 10 as well. So, or in I guess in an easier term, we're just moving the decimal 1 over until it becomes a whole number. So in this case, we needed to move it once to the right, and it becomes 85, right? Because we moved the decimal from here, from that spot, and it becomes here. And inside, we move it 1 spot, and it becomes 807.5. Okay, I'm going to erase this decimal because it get a little confusing. Okay, so our new division problem is 807.5 divided by 85. 85 doesn't go into 8, doesn't go into 0, but definitely goes into 807. I'm going to say 9 times. And 85 times 9, right? 45, carry the 4, 72, 76. 72 plus 4, 76. So 765. Let me bring this decimal up so I don't forget it. Subtract. A little help here. 10 minus 6 is 4. 42, bring down the 5. And 85 going to 425, maybe 5 times. Let's just see. 85 times 5 is 25, goes 2. 8 times 5 is 40, 42. Oh, look at that. I'm sorry. 5 times and you get 425. So, how much does she make an hour? She makes $9.50 an hour. Is 34562 divisible by 12? No idea. Use the divisibility rules to explain your answer well. The divisibility rule for 12 says that if it works for 3 and 4, it will also work for 12. Because another way of thinking of 12 is thinking of it as 3 and 4. So let's check. Is it divisible by 3? Well, to be divisible by 3, you got to add all these numbers. 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18, 18 plus 2 is 20. Is 20 divisible by 3? No. Is it divisible by 4? Well, we have to check the last two digits, right? 62. Is 62 a multiple of 4, or is it divisible by 4? Well, 4 goes 62 one time, 2, bring the 2 down, 4 goes 22, 5 times, going to have a remainder, so definitely doesn't work for 4 as well. So, if it doesn't work for 3 and 4, actually, if it doesn't work for 3, period, or just 4, period, it won't work for 12. So it does not divide nicely. So, but it did say for us to divide it anyway using long division. Here we go. 12 goes 34 2 times, which is 24. 10 left over, bring down the 5. I'm going to say this is a 8. 12 times 8 is 96. 9 left over, bring the 6 down. 12 goes 96 8 times. It's a 0, right? Bring the 2 down. Can 12 go into 2? No, it can't, so it's a 0. And so this problem is going to be, the answer is going to be 2,880 with a remainder of 2. So definitely, we already knew that it wasn't going to be divisible because we checked using our divisibility rule. What is a quotient? What is the answer to this problem? So here we got to change both problems to both improper, I'm sorry, mixed to improper. 3 times 4 is 12, 13 over 3. Divided by 6 times 1 is 6 plus 5, 11 over 6. Here's our division problem. Let's find an LCM. LCM between 3 and 6 is 6. All right, so this changed. 3 times 2 became 6. And then multiply the top by 2. So 13 times 2 is 26. So here's our new problem. 26 over 6 divided by 11 over 6. We can cross. Gives us 26 over 11. And 11 goes 26 2 times, which is 22. 3 left over 11. Final answer. And finally, our last problem. Replace A and B. So we have a number that looks like this. 2 blank 3 4 blank with digits so that it's divisible by 2 and 7. To be divisible by 2, it has to end in an even number. And to be divisible by 7, we double the last one. Ugh, this, and ooh. I shouldn't have said 7. Oh, let's try anyway. Yikes. You know what? If you get to this, because 7 is just ridiculous, let's make this so that's divisible by 2 and let's change this. 2 and 9, okay? 7 is just ridiculous. Hopefully you'll catch it by the time you see this video. So, replace A and B by 2 and 9. No, actually, I'll change the sheet. So, to be divisible by 2 and 9, it has to be an even number, and all the sum of all the digits have to be divisible by 9. So, let's pick an even number. 4. Now I know it's divisible by 2. Now, for this to be divisible by 9, I have to add it up. Whatever number I get has to be divisible by 9. So what do I have so far? 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 4 is 13, right? So the next number that's divisible by 9 is 18. So 18 minus 13 is 5. So to make it divisible by 9, I need to add a 5 here. Let's see. 2 plus 5 is 7, plus 3 is 10, plus 10 is 14. I'm sorry, 2 plus 5 is 7, plus 3 is 10, plus 4 is 14, plus 4 is 18. So the sum of this is divisible by 9, and the last number, because it's even, is divisible by 2. Okay? So that's it. I will Make that change there so you don't go crazy with the 7.